Welcome back to Zuluwa Consultants. In this video, we want to learn how we identify the conjugate base and the conjugate acid. Do not forget to subscribe to our YouTube channel and follow us on our Facebook page if you have not done so. We have two equations. We will use these equations to show how you can identify the conjugate acid and the conjugate base. For us to answer this question, we need to remind ourselves the definition of an acid and a base. We have so many definitions of an acid and a base, but of interest, we are going to define an acid using Bronsted. The definition of an acid, according to Bronsted, is that an acid is a proton donor, while a base is a proton acceptor. So according to the definition we have just said, when there is a reaction between an acid and a base, there is a transfer of a proton. Now, a proton is basically H+. So, when a reaction is taking place between an acid and a base, we are saying H+ is transferred. We have defined an acid and a base. Now, what is a conjugate base and a conjugate acid? Remember, we are saying when a reaction between an acid and a base is taking place, there is a transfer of a proton. Now, what remains after a proton has been transferred is the conjugate base. Then where the proton goes, that is the attachment the proton makes with a base, that is what we call the conjugate acid. So remember, what remains is the conjugate base. What is formed between a base and a proton is a conjugate acid. We have the first equation here that has been moved this side so that we can analyze it easily. Let us look at the equation that we have and start with HCl. Now, you can see that HCl is reacting with water to produce these products. Now, when you look at HCl, what is the major product that can be associated to HCl is Cl negative. Now, how is Cl negative being formed? This is as a result of HCl donating a proton. Remember what we said a conjugate base is. We said a conjugate base is what remains when an acid donates a proton. So already you can notice that this is the acid. So what is remaining when this acid donates a proton? We are saying the conjugate base is what remains when an acid donates a proton. So what is remaining is Cl negative. Then, when a proton is donated to a base, what is formed between a base and a proton, we say that is a conjugate acid. So the conjugate acid is what is formed as a result of a base reacting with a proton. So what is formed as a result of a base reacting with a proton is H3O positive. So this is the conjugate acid, then we can say in this equation, water acted as a base. So we have identified HCl is an acid, water is a base, H3O positive is a conjugate acid, and then Cl negative is a conjugate base. In the second example, we have NH3 reacting with water to form NH4 positive and OH negative. Now, how do you identify which one is the conjugate acid, which one is a conjugate base? Well, let's look at when you get NH3. Now, we can link NH3 easily to NH4 positive. When you look at these two, NH3 and NH4 positive, you can notice that a proton was donated to NH3 for it to become NH4 positive. So a proton was donated. Now, where is this proton coming from? It suggests that this proton came from water. So the reactant that donates a proton acts as an acid. So in this equation, water was an acid. Then what receives the proton is a base. So NH3 is a base. Now, which one is the conjugate acid and a conjugate base? For a conjugate base, we said this is what remains after an acid has donated a proton. So what is remaining after water donates a proton is OH negative. So OH negative is the conjugate base. Then the conjugate acid is what is formed when a proton reacts with a base, which is NH4 positive. So we have identified that this is the conjugate acid and this is a conjugate base. Hope this video has been very helpful to you to see how we identify the conjugate acid and the conjugate base. See you next time.